Okay, let's continue talk about the question 2. It is suggested as the following function of v. First, f v equals to v square quadratic minus v absolute. The function b is f v equals to sine v square over v square. The function c, f v equals to 1 and 0 when 1 is absolute smaller than alpha and 0 is absolute larger than alpha. These three functions may represent an autocorrelation function of the WSS stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega or both, which functions fv may represent either or both. Explain your answers. When we do this problem, we first need to figure out the how to represent an autocorrelation function or how to represent a spectral density function. First, if R tau is an autocorrelation function of a real WSS stochastic process xt, then it is even and R tau smaller than R0 and its Fourier transform is non-negative if S omega is a power spectrum of a WSS process xt, then it is non-negative. Okay, we know about the definition and how to prove it. Then we look at the first function a, f v equals to v minus v absolute. It may represent the autocorrelation function because v is even, right? And v smaller anytime v equals to alpha which is non-negative. We use the cosine h and sine h properties. 2. It may represent a power spectrum also because E minus omega larger equals than 0. The function b, fv equals to sine v square over v square. It may represent the autocorrelation function because first tau, this is even, right? We know that this is even, and the function, the above function sine tau square and the tau square are both even, so we can get that this function is even, and sine tau over tau square smaller than limit tau equals to 0 sine tau square or it is equal to 1, right? So sine tau square over tau square smaller than when tau equals to 0, and sine tau square, which is equals to the graph. We can draw the graph of the function. It is 1 minus 2 to omega. We see from the graph that it is non-negative. So we prove it. The function C. Sorry. I did not prove that it is a power spectrum. To prove a power spectrum, it is easy because omega square sine omega square, it is larger than 0. Let's look at the function C. Fv equals to 1, 0 v alpha v absolute larger alpha. Or we can see from the the diagram, the question provided. We can see that it is obviously non-negative, but it cannot present an autocorrelation function because its Fourier transform is 2 sine omega alpha omega over omega. It is not negative. It is not non-negative, right? Since we did not know the since we did not guarantee that the 2 sine alpha omega is always non-negative. But it can present a power spectrum because f omega, which is 1, 0, are always larger than 0. So it can present a power spectrum. That's all of the proof that the 3 function, if it can be an autocorrelation function or if it can be a spectral density function. That's all. Thank you.